Hello and welcome to this physics video, complex resistor combinations, U11.CRC2. And today we will be calculating the current in and potential difference across individual elements within a complex circuit. So let's get to it. Find the current in and potential difference in the circuit. And here's our circuit here up close for you to see. First, what we need to do is find the equivalent resistance. And to do that, we first need to deal with this little parallel part right here. So what I'm going to do is find that value. And I have to use, for parallel circuits, to find the equivalent resistance, this is how you do it. You don't add it like you do in series. So let me get out my trusty calculator. And we get a nice 1.5 for that. So now we can rewrite this to make it easier for us to see. Uh, 1.5 ohms, 2 ohms, and 4 ohms. Okay, so now to find the equivalent resistance of the circuit, all we need to do is add all of these values together. So that's going to be 1.5 plus 2 plus 4. And that is going to be 7.5 ohms. So now we have that. Now the next thing we need to do is find the total current of this circuit. So for that, we're going to need to use this equation. We have the total voltage, which is right here, 8 volts. 8 equals, and then our total resistance, 7.5. Let me go to the calculator. And I get this value for my total current of the circuit. Okay. So now we need to find the individual current in and potential difference of everything. So first, what we're going to do is we're going to stick with this. The hardest part, I'd say, is to finding the individual parts of the parallel circuit, because we kind of have to work backwards now. So for this part, we're going to leave it at 1.5. We know that's the resistance of it. We know the current is going to be, let's see here. We need to find the potential difference across this point. So we get V equals 1.5 times the current, which is 1.1. And the value that we get is 1.65. That's the voltage for that part. So now, knowing that, we can go back here. And we know that in parallel circuits, the voltage for each resistor is the same as the voltage or the terminal voltage. And in this case, the terminal voltage is going to be, or the potential difference of the circuit is going to be 1.65. So all we have to do is 1.65, and we need to find the current of this right now. 1.65 equals 3, because that's the resistor, and then we need to find the current. So we need to do 1.65 divided by 3. And we get 0.55. And that is our current. So now I feel like I should start listing all of these currents and potential difference across each resistor. So let me label these for you really quickly. We get R1, R2, R3, and R4. So R1 is going to have a current of 0.55 amps and a potential difference of 1.65 volts. And R2 is going to have the exact same because they have the same resistor value. Okay, now we need to find so for resistor 3, we need to find the potential difference right there. We know the current. The current is going to be 1.1, as we found earlier. It's going to be 1.1. So we just need to do a little more math. It's going to be 1.1 times 2, and that is going to be your potential difference for that resistor. So that's just going to be 2.2. So the current is going to equal, let's see here, 1.1 amps. The voltage is going to equal 2.2 volts. And lastly, resistor number 4. The current is going to, let's label this really quick. V equals 1.1 times 4. We already know that the current is going to be 1.1, and that just leaves the voltage, which is going to be, let's see, 1.1 times 4 is just going to be 4.4 volts. And there you have it. That is the individual values for the current and the potential difference across each resistor. So thank you for listening, and I hope you enjoyed the video.